To understand closures, we first have to understand the fundamental concept of scope in JavaScript. When you create a function, you also create a brand new private universe for its variables. In this diagram, you can see function outer. Inside it, variable A is safe from the outside world. This inner scope can access anything defined on the outside, like the global variables, but the global world cannot see variable A. This simple hierarchy is the foundation of all JS security. That's where the magic happens. Let's look at a typical function call. It runs, it cleans up, and it disappears. Now, look at the closure on the right. When the inner function is returned, it creates a visual connection, a snapshot, of the entire environment where it was born. It literally closes over its parent's variables, retaining that state even after the parent function has finished executing. It is a persistent memory of its birth. Let's use an analogy. In standard programming, loose variables are like keeping your data in an open pile. Efficient, but messy and prone to conflicts. A closure is like a specialized, persistent data box. When you call the closure, you aren't just accessing a function, you are reaching into that specific box of memory. Loose variables leak, closures are sealed, ensuring your data is accessible only to the functions that own it, preventing accidental overrides and keeping your logic modular. Let's see it in the code. We are using closures here to manage state and privatize data. We create a counter function that is a closure. Inside, count is defined in the parent scope. The returned function can read and modify count, but nothing outside can touch it. Each time we call myCounter, it updates its own private state. This is how we build secure modules without cluttering the global namespace or relying on external state managers. This pattern is the core of sophisticated JS design, including the revealing module pattern. Before modern ES6 classes, developers used closures to simulate private variables. But even today, closures offer elegant solutions that var self-equals this hacks never could. This blueprint shows how we build complete self-contained modules, exposing only the public methods while hiding the complex data logic inside a robust closure system. This is true advanced engineering. The key advanced takeaways for mastering closures are: first, JavaScript functions are lexically scoped. They always have access to the variables defined where they were written. Second, closures allow functions to retain a persistent reference to their initial creation environment, creating private state. And third, these private data boxes enable us to write clean, secure, and highly modular code. You've now mastered one of the core principles of professional JavaScript development.